Assalamu alaikum wa rahmatullah. My name is Muhammad Al Khair Arif. I'm a final year mechanical engineering student. Today, we will be speaking about corrosion and the ways of preventions, such as coating. So stay with me on the show and let's go. Corrosion. The process by which metal slowly broken down by reacting with substances in their environment. Oxygen and water are present in the atmospheric air. When they react with iron, they form hydrated iron 3 oxide, which is commonly known as rust. Here is a picture of a wrench. When it reacts with oxygen and water vapor in the atmospheric air, it forms a rusted wrench that consists of hydrated iron 3 oxide deposits on it. The half chemical equation says that iron undergoes oxidation, which means that iron loses 3 electrons to form iron 3 ion. On the other hand, oxygen is reduced by gaining 3 electrons to form 2 atoms of oxygen ions. This reaction is called redox reaction, as it involves oxidation and reduction. Conditions required for rusting to take place. As we have earlier discussed that metal react with water and oxygen in the atmospheric air to form rust. So let's conduct an experiment. We have 3 test tubes. The first test tube contains water that has been boiled to remove all oxygen, and then a thin film of oil is placed on top of the water to ensure no much diffusion of oxygen into the nail. The test tube is then sealed to ensure that the condition within the test tube is maintained. The first test tube then has water but no oxygen. However, the second test tube has the same condition, except that water has been drawn, which means that there is an oxygen but no water. In the third test tube, it is filled with water and oxygen. So, which nail is going to rust? Yes, it's the third, as rust will only happen if the condition of water and oxygen are present.
Much of the equipment that is used in the oil industry is bolted in place, often at height. Here it is exposed to adverse weather conditions. If we choose the incorrect method of securing the equipment, galvanic corrosion may occur, and the equipment may fall down.
Galvanic corrosion. It is an electrochemical process whereby one metal corrodes in preference to another metal that is in contact with through an electrolyte. In this example, we have a stainless steel plate and a galvanized steel screw. When the plate and the screw are in contact with each other under the water or a damped environment, the galvanized screw will become the anode and the stainless steel will become the cathode. And as we know that anode always corrode. But why? In the galvanized series, we could see that stainless steel is more positive than the galvanized steel. Since the galvanized steel is more negative, it tends to become an anode, as less noble metals become anode and more noble metals become the cathode. Moreover, galvanic corrosion may also occur between parts of the same metal if the parts are placed in a different surroundings, such as areas with different pH values. However, for this to happen, the cathode and the anode must be in electrical contact with each other.
One important thing to understand with corrosion is that it's only the surface of a metal that corrodes. This is because only the surface is exposed to substances in the environment, like water and oxygen. When iron rusts, though, the rust that forms at the surface gradually flakes off, revealing new metal underneath. This means that the next layer can also rust, and over time that bit will fall away as well. So if left long enough, the entire chunk of iron can break down until there's nothing left. In contrast, when metals like aluminium corrode, it's only the surface atoms that are affected. This is because when the top layer of aluminium atoms is oxidized to form aluminium oxide, they effectively form a protective layer around the piece of aluminium, which protects the rest of the metal from the environment.
Here are some points of good practice to prevent galvanic corrosion. Obtain an overview of the types of materials used in the equipment and structure to which the equipment will be fastened. Choose bolts that are appropriate to the relevant load and surroundings. Remember the basic rule. In a corrosive environment, try to use metals with the same or almost the same nobility. If you must use different materials, you can use washers to prevent the materials from coming into direct contact with each other. An alternative method of preventing contact between the materials is to paint the surface. Remember to paint the most noble part, the cathode. If you paint the anode and a crack forms in the paint, the galvanic currents will flow to this point and may result in significant corrosion. Note that cracks in galvanized materials may also result in similar problems. The size of the cathode surface area exposed to water or another fluid determines how quickly the anode will corrode. For piping connections, follow the pipe spec to ensure that bolts and packing rings used in flanged joints are made of the correct material. If piping of two different materials needs to be connected, isolation spools can be used. In seawater systems, the isolation spool should be at least 10 times the piping diameter. The isolation spools must be non-conductive, such as GRP, or treated internally, such as with an epoxy paint or vulcanized rubber. Isolation spools are not recommended on hydrocarbon-bearing piping. Consider using sacrificial anodes in order to protect metals in seawater and thereby prevent corrosion. Frequent inspections can also help to prevent galvanic corrosion causing accidents or near misses.
Corrosion of metal cost the United States government almost $300 billion a year, which is 4.9% of their GDP. Coating, along with the improved manufacturing practices, had reduced the cost of corrosion by 35% according to ASM International. So what is coating? A thin layer of covering substance applied on a surface of any metal, mainly to create a protective barrier against deterioration of a surface due to its reaction with substances present in its environment. There are two methods of coating. The first one is barrier method. It prevents oxygen and water from touching the metal, mostly used in ship hulls by painting them, as paint prevents oxygen and water from reaching the metal. Oil, greasing, and lubrication is used for rotating parts. And the last one is electroplating, which is the use of electrolysis to cover iron with a different metal that is more resistive to corrosion. The second method is the sacrificial method, which is actually adding more reactive metal to corrode instead of the main metal, which is iron. So for example, aluminium and zinc, they are more electronegative, which means that they will corrode instead of iron when they are present or when they are in contact with iron. With that being said, we hope that you have developed a clearer picture on corrosion and the ways to prevent it. Thank you so much and have a good day.